So, very good morning, students. Now we have to see mathematical treatment of unit number 1 on dielectric properties of insulating materials. We have seen 2-3 lectures on this. I will just recap what we covered in this unit earlier, and then we will see the derivations. Okay. So, we have seen the curriculum of the syllabus is static field, parameters, dielectric materials, all the simple definitions related to polar, non-polar material and types of polarization, polarizability. So this part we have seen. And then I introduce you the polar and non-polar materials also. What is the difference between the polar and non-polar materials also, that also we discussed it. And then now polarization types, electronic, ionic, orientation, polarization, that was also discussed in the last session. Now today we will see Clausius-Mossetti equation, and after deriving this, then left up the part will be again piezoelectric, pyroelectric, ferroelectric, that we'll see in tomorrow's lecture. So tomorrow, by end of tomorrow, this unit will be covered, and you start preparing for the unit test. That will be next Monday. So 3 days you will get. Friday might be holiday, I don't know, but Saturday, Sunday holiday is there. And in unit number test 1 on Monday's first lecture, you have to score 10% marks. That is what my expectation is there. So first unit will be covered by Monday. We have seen difference between dielectric materials and insulating materials. I told you, you know, the insulating materials, conducting materials, semiconducting materials. So insulating materials are those materials which will not allow to flow the current. It doesn't mean that current will not flow through that material. Current will be always flowing, but that will be very small, microampere. So that is called as leakage current. But property of this insulating material will be to oppose the flow of current. So in your house, I told you, if you are considering the current is passed through the conducting material, see, coating on that wire will be PVC, VIR wires. So when you will touch to your wires, you should not get shock. Current has to flow through the inside conductor. So insulation is used where you don't want to have current flowing. In current is not intended to the flow. It should insulate the current. And therefore PVC, VIR wire, we have seen insulating materials. But there is a small difference between dielectric material and insulating materials. So dielectric materials, all dielectric materials are insulating materials. But the main purpose of dielectric material will be for storing the charge. So they are using capacitors, and we have seen dielectric metal examples: oil, paper, mica, ceramics. And insulating materials: VIR wire, PVIR, PVC. VIR means vulcanized Indian rubber, PVC, polyvinyl chloride, bakelite. So I told you, you remember all these characteristics, definition in comparison form. So assignment number 1 is given, and I will require assignment 1 submission by the end of Friday. Okay. So that your preparation will be also ready. So complete assignment number 1 by Friday. 5 I think comparisons are given, and you prepare it. Try to increase the number of points, because comparison I have also discussed in the lecture, but you start increasing the points. I have given additional points also. Picture will be there, applications will be there. And then we saw basic definitions. That was the revision for you. Coulomb's law, what is the force given by, so that we discussed. Then electric field equations, intensity equations, I told you to remember these equations so that you will be able to derive also. You must prepare for the conventional exam. Conventional exam, because we can't predict, and you have to prepare for the conventional descriptive type exam, because your exam might take place in November, December, if a normal situation is arrived. So at that time, you should not just go in the confidence that no MCQ and online. No, start preparing for your regular conventional exams. So flux density equation we have seen, and then I told you flux density is equal to epsilon E. You also know, but that was some revision. And today also this is recap only. So dielectric constant D is equal to epsilon E. So all these basic definitions we have just seen. I told you to remember equation 7, 8, 9, because that will be required for derivation. Then we just saw who win the competition. So competition I took it on Kahoot. So that was just checking your how you are attending lectures. Dipole moment, then I introduced this is the new concept. So dipole moment, when two equal and opposite charges are displayed each other with some distance, they constitute dipole moment. So dipole moment is denoted by small p, which would be product of charge into distance. So it is a vector. So direction is very important. So unit of dipole moment is dB, and dB means how many coulomb meters. So 1 dB is equal to 3.33 into 10 raised to minus 3 coulomb meters. So you have to remember units and conversion also for simple problem. Then we have seen the definition of polarization. I've shown you the animated video. So I think your concept of polarization might be ready today, and you must be able to explain the polarization. So total polarization can be defined as the number of total polarization per unit total dipole moments per unit volume. Okay, so P is equal to N into small p. This small p means dipole moment, and we have seen polarization is equal to epsilon 0 epsilon E. So this is epsilon into E. Okay, so then electric susceptibility and susceptibility and polarizability, we have seen the definitions. Okay, so let us start today derivations. So write down in your notebook. Today we will see derivation, permeability, this equation epsilon, or you know the relative permeability. Relationship between permeability and polarizability. Write down. Relationship between permeability and relative permeability and polarizability. So polarizability is alpha. Okay. Polarizability alpha. So let us see dipole moment. We have seen dipole moment small p. Dipole moment is small p is equal to charge into distance d. Okay, this equation is 7 we have seen. Okay. Now, polarization. Polarization is capital P. Polarization is, we have seen number of dipole moments per unit volume. So this is the basic equation we have seen according to definition. Polarization is equal to capital P is equal to number of dipole moments per unit volume. But we have seen this equation as epsilon 0 susceptibility. Now susceptibility you just draw like this XC, because that typing I could not get that symbol. Okay. So polarization is equal to dielectric constant into this susceptibility into E. This equation 8 we have seen it. Okay. Equation 8 we have seen it. So here this you can substitute. Polarization means number of dipole moments. Okay. Number of dipole moments. So I can say that number of this dipole moment will be equal to epsilon 0 susceptibility XE into E divided by N. Okay. So that is equation for dipole moment. But we have also seen equation dipole moment is nothing but alpha into E. So what is alpha? Alpha is polarizability. This we have seen definition, difference also, polarizability. And its unit we have seen farad meter square. Okay. So this also we have seen equation, I think it is ninth, equation ninth. So from this we can say that polarizability alpha is equal to dipole moment divided by intensity E. Now, how you will remember polarizability and susceptibility? Here, I will give you the hint. I told you to remember in comparison form. But here again, I will give you hint how you will remember susceptibility and polarizability. So, susceptibility is X. Susceptibility is X. So, when you say dipole moment will be in terms of susceptibility. It is a constant of proportionality for dipole moment. But when you see P, polarization. Then you can see this polarizability. Polarizability is equal to this dipole moment is equal to polarizability into intensity also. Okay. Dipole moment is equal to alpha into E. So constant of proportionality for dipole moment is alpha. Okay. Now alpha is equal to dipole moment divided by E. But this dipole moment you can substitute value. Suppose this is equation 10. Now write down substituting equation 10. So substitute. Now what is equation 10? Dipole moment is epsilon 0 susceptibility E divided by N. So this is dipole moment. We have substituted this value divided by E. So this E will get cancelled. E will get cancelled. So what equation you will get? Alpha is equal to what you will get? Epsilon 0 susceptibility divided by N. Okay. So remember this equation for polarizability. Remember this. Number of equations you have to remember. Okay. Now, we have seen what is polarization. So, you know D means electric flux density D. And we have seen when you will see this electric flux density in free space, you know normal equation D is equal to epsilon 0 epsilon R into you know if there is a no free space but relative permeability. But we have seen when you will see electric flux density in the this free space, then polarization you will define as polarization is nothing but the flux density which is observed. Due to polarization, flux density will increase in the material. So this equation we can write down. Total flux density will be flux density produced in free space plus flux density produced due to the polarization. So remember this equation D is equal to epsilon 0 E plus P. Okay. So what will be P from this equation? Polarization P will be equal to D minus epsilon 0 E. Okay. Or we can say that, see, suppose this is O. Forget this. First, you know D is equal to epsilon 0 epsilon R into E. You know D is equal to epsilon 0 epsilon R E. Okay. So, this will be epsilon 0 E plus P. Okay. Plus polarization P. So, polarization will be equal to, take it to the left hand side. So, it will be epsilon 0 epsilon R into E minus epsilon 0 into E. Okay. So that will be polarization. Now from this what you can take common? Epsilon 0 into E. Here also epsilon 0 into E is common. So take it that common. Epsilon 0, epsilon 0 into bracket epsilon R minus 1 into E. Purposefully I am writing in this way. Epsilon 0 I am writing here and E I am writing there. Now, you know that polarization P is equal to this equation you have seen. Polarization P is equal to, you have seen, epsilon 0 susceptibility Xe into E. This equation you have known from equation 8. Okay. So epsilon 0 X in susceptibility into E. So you can say when total polarization you will consider, it will be susceptibility. But when you will consider dipole moment, at that time polarizability is there. So this hint I wanted to give you. When you are considering polarizability, it is a constant of proportionality for dipole moment. When you are considering susceptibility, you are considering it is the constant of proportionality for polarization. Okay, now from this equation, what you can say? Susceptibility is equal to epsilon r minus 1. So this equation we have derived it. Susceptibility is equal to epsilon r minus 1.